So, on the previous video we saw the anatomy of the point. So, at this point you're probably able to make a grid system like this. Okay, have your different prefabs with their own points inside of them. There's no need to be connected. And so you have a game object that has all your prefabs with client points in it. Now let's see how we can actually connect them all together without having to worry about going into each point and connecting it manually. On our parent game object, we're going to go and create the handle points connection. It's going to run on the Unity editor, okay, only in editor, it's not runtime, although with a few changes you can do it to have to run this on runtime, but you know, because you might have a lot of points and a lot of lists, you just have to think a little bit about the performance. Of course, this can only run once and doesn't have to run more than once basically, unless you're going to do changes on the grid. But even if you do dynamical changes on the connection on one of the points, you still have all the connected points, so you can reconnect them again. Okay, but yeah, that goes out of scope of the purpose of the series, and it's pretty, yeah, let's keep it simple for now. So basically what we need to know when we create a grid, we need to have in mind a few variables. The distance between one point and the other. Okay, so if it's further away, okay, there's no connection, you cannot reach that point. If it's close, then what type of connection is it a one-step transition or a two-step transition and all that. So how we handle this? Minimal distance is if it's lower than 2.5, that means we can actually connect from one point to the other. If it's higher, that means you cannot reach that point from the point you are right now. Direct threshold is the threshold if it's going to be a two-step transition, okay, when they are side by side, or if you have to jump towards that point. Update connections and reset connections. Reset connections basically goes into your points and clears all the connections, all the neighbors. And update connections is what we're going to see right now. We need a list of all our points, and we also need a list of the available directions, and this is where you have to pay attention a bit. Available directions. What available directions is basically all the directions we can connect a point towards to. That means I can connect on the right side of a point, on the left side of a point, up of a point, down of a point, diagonally on -1 and -1, so down and left, up and right, up and left, and down and right, left and down. I think the order in this might be important, so make sure you, I don't remember right now, but make sure you have the exact same order we have over here, okay? Although in the end it might not be needed. Anyway, okay, here's how we initialize our directions. Of course, this is going to execute in edit mode, so we don't want it to run only on start. So on update, we're going to say if we want to update the connections, we have a function that what it does, gets all points. clears the current list of all points we have, and goes into the children and gets all active game objects that have the component point, and it adds at range, it adds all the points you have found, it adds them on the list. Okay, we have all our points. We need to start creating the directions, which is this one, which is what we want to connect. So we can start creating connections. So we go for each point we have, or 4 point, it's a for loop, I'm just saying for each. Okay, we have a current point and our available directions. If I do not want him to move diagonally in my directions, I'm going to remove all this if I do not want him to move diagonally. And here's where we can start thinking about how we can handle the connections. We have our point. We want to see on direction, let's say left, we want to see to find all the other points that are on our left. Okay, because this is a list, there's no order inside the list. Okay, so what we do over here, we come into this function which is candidate points on directions. We pass our available direction, the direction we are looking at currently, and our current point. Candidate points on direction. It's going to return us a list of points, and what we have, we go and look inside our list. We assign the target point to be right now the entry we are currently looking at, and we find the direction from the target, from our position towards the target point. We turn that into a relative direction into local space, since the directions need to have, we need to think, we need to take out of the equation the world rotation. So we need to think everything as local positions. Since the directions are hard-coded into -1 and to 1, that's why we need to look into local positions. Otherwise, if you rotated your claim system, you will be getting wrong values. So we need to find the relative direction. So we have our relative direction basically. If the direction is valid, and we will see what this is where the most of it is. To compare, to see if our direction is valid, we need to pass our target direction and the newly created relative direction. And if it's valid, then we add it into our return value and we return that into our list. We return that over here. Let's see how is direction valid. It's over here, it's just a simple bool. We start with false, and we need to find the target angle. So how we do that? We use the attenuation tool of our target direction X and target direction Y, and we turn that into degrees. We need to find the angle for our candidate, and we need to also add a little bit of offset. Otherwise it's going to take connections and it's going to be very hard coded, so it will only return true if it is at the exact same angle. We're actually going to open Paint right now. So I hope you can see we are at this point and we want to move on the left. On the left is -1. So we have one point over here, one point over here, other points, you know, all the other points we can have. What we do, the direction we want to have is -1, -1, 0, 0. Okay, so the attenuation is going to return us on the x and on the y, it's going to return us an angle between -1 and 0. So basically it's going to return the angle that this is. It's going to turn that into degrees. So if I'm not wrong, then for the left direction it's going to return 0. That's okay, it's going to return 0. So we add a little bit of offset into our 0. Well, let's say it's 0, even if I'm wrong. Yeah, I cannot think right now. Okay, we have our target angle will be 0. We add an offset, a positive offset, which will be 22.5. So it will automatically be like this. Okay, yeah, somewhere like this, not exactly like this. And we also add the same value on the negative, so we get something like this. So we have our circle over here. Let's say this is the middle point. With the offset, it's going to be something like this. So we check the relative direction we have over here. We also check the angle between the relative direction, and if it falls inside this, if it falls inside this degrees, or our target, our threshold for our angles, then that means it's a valid point. So it's actually a point based on the direction we want to move. Okay, so it means it's on the left in our current case, and we do that for all our points and for all directions. Okay, it returns its direction value. If it's inside, it's going to return true, and it's going to add it into the return value candidate points on direction. Return closest. Okay, we only want to have one target point towards every direction. Okay, since otherwise, if you're pressing left, you can only move towards one point at a time. So we need to find the closest point, which that is what makes the bigger sense. We pass the list of points and the from. So for every valid point, we check the distance, the minimum distance. We set it as mathf infinity, so the first one will always override this. Temporary distance. If the point is if its temporary distance is lower than the minimal distance, and it's not the same point as the one we're coming from, then it's going to assign the minimal distance the temporal distance, because the list of valid points is going to also return our own point sometimes. Okay, so we need to check that we're not taking our own point. It's going to update the minimal distance, okay, and so on and so on, and it's going to return us the closest point towards our current point. If, of course, closest is not null, it's just a fail safe, we're going to start checking at the distance. If the distance between the closest point and our point is lower than the minimal distance, that means we can reach it. if it's higher than the minimal distance, then that means, you know, you can connect to that point if the closest point is so far away. So if it's lower than the minimal distance, we can go. And here's this, yeah, let's skip this part for now. We add it on the neighbor. Okay, we add our neighbor, our current point, closest point, and available direction. What this does is basically, because I do not have any jumping animations that go diagonally, and good luck finding diagonally jumping animations, and they pretty much create a little bit of problem by jumping with the arcade and the way it's set up over here. Okay, so what I did is eliminate diagonally jumping. Eliminate diagonally jumping. How we check if we are moving diagonally? We check the absolute value of the y and the x. If it's higher or lower, if it's higher than 0, then that means we're moving diagonally, and we're going to check the distance, and if the distance is higher than the direct threshold, then that means you want to jump, so skip this part, do not add it on the neighbor. Okay, so we have our current point, we have our target point, which is the closest point towards that direction, and we have the direction. We have this function, and we say add neighbor. It creates a new neighbor, it creates the target direction, which we were looking right now, the target, and what type of connection type it is. We check the distance. If it's lower than the direct threshold, then it means it's an in-between, so that means a two-step transition, or direct one-step transition, so basically jump there. And we also need to, of course, add it into our current point onto the neighbors, the newly created neighbor we have created over here. And for this to update, and because we are doing this on edit mode, okay, we need to set dirty, otherwise when we hit play, it's not going to save our list. Okay, so it's going to empty your list because these lists are created in the editor. You just need to call the editor utility, set dirty, and pass the object you actually want to set dirty. Okay, which is our current object. And what this is going to do is go into one point, find all the connections for all the directions we have set up, to what point it can connect, and it's going to go and create connections. Okay, it's going to come into each point and create all this, so you do not have to write them manually and drag and drop them manually. Of course, this script doesn't actually need to be onto one game object. I have a ledge over here. Okay, the prefab. It has the handle points that we see how create them, and yeah, it already has the connections and all that. But I've added on the ledge, which is on the prefab, I've added the handle points connection over here, and I'm going to add also a draw line, which we saw what that is. I'm going to reset the connections, which goes and empties the neighbors list, and I'm going to hit update connections, and of course, because all the points are in order, you just see a green line over here, and you can see that the directions are all created. If I start adding more like this, hit reset connections and update connections, okay, boom, just like that, you saw how easy it is. I've created more connections, and I can continue making on. As you can see, as I said on the previous video, the model and the visual part doesn't have to do anything with the climb points. This doesn't even have colliders on it, and we actually only use a raycast once when we are grabbing on the climb points. Okay, reset connections, so we get rid of all the other ones. Update connections. Okay, pretty sweet. And there's, yeah. Let's go back to the scripts. After we have created the connections, we need to handle the dismount candidates, which is over here. Let's see the dismount candidates. I'm going to duplicate the last one. Let's go. Yeah, that won't work because it's way too far up. So let's delete these ones, and it might give us, let's close this because it might give us an error, and it did. And that's not good. Let's hit refresh, so it clears the list inside the draw line. Let's put this one over here all the way to the top. It's a long way to the top if you wanna make climb systems. So, okay, we have our climb point. Let's say this is where you can actually get off. As I said, you do not have to have the model. And I'm going to click dismount point. So I'm indicating that you have to, you can get off over here, you can dismount. So it's going to come over here, it's going to load the prefab for the dismount. If it's null, if it cannot find it inside the resources folder, which is named dismount, it's going to throw a debug, of course. It's going to get all the handle points, and the handle points is not the actual points, it's the handle points is the script, okay, where we help. And we're going to create a new list of candidates, so we're going to check for all the handle points we have if somebody is a ticked dismount point. If it is, it's going to add into the candidates all its points. So when you're updating this, let's copy paste it over here one more time. Okay, so when I'm updating the connection, it's going to look this climb point. It's going to connect the points and the points between these two, and then it's going to look on the handle points over here. For this one, it's going to say not dismount point. For this one, it's going to say dismount point. So we add it into the list of candidates. For every candidate we have, we create a new game object. We set the parent to be the same as, we should probably use this candidate.transform. Oops. Let me think. Let's take the first candidate. Oops. Yeah, that's the wrong place. I think it was transform. Yeah, I'm going to change this to position. So it's going to create a new game object, which is going to be the parent game object. We change the name to dismount point. No. Anyway, let's move. Okay, it's going to create and update its position and all that, and its parent and all that. And for each point we have inside our candidates, it's going to go and create, it's going to find the wall position, it's going to create a new dismount object. So it's instantiating the dismount prefab on the wall position. We have the same as the parent and the same rotation. The target position is going to be on the wall position, which is the current point we are looking at, a little bit further forward, which is forward subdivided with 1.6, plus a little bit on the top, and this is a little bit too high, I believe, so let's make it 0.2. And okay, this just finds a random position. We can add a lot more stuff over here. We can actually add raycasts and all that to make it more, even more automatically. But yeah, this just goes, it makes it complicated without any particular reason. That's just my opinion. So we set up the dismount object on the target position we have just found over here. We assign the dismount point, we have it over here. We create a neighbor for direction up. The target will be the dismount point, the connection type will be dismount. We add into our neighbors, we add the neighbor over here, and this will be P. Okay, we create a second neighbor. Basically we have to create two connections, one for the point that we're looking at and one for the dismount point. Okay, there is no interconnection between dismount points, and there is also no connection, there's no diagonal movement and all that. You can only dismount from straightforward. Okay, so we create a new connection. The direction will be the opposite. The target for the dismount point will be the actual point. The connection type will be also dismount. Later on we'll change this into mount or something else, so we can jump from on top of the ledge down. We add that into the neighbors, and we also change the parent to be the parent object. Okay, simple, very simple. Connections, the connections are this, which, yeah, we found the dismount candidates, and what this will do is, if I hit update right now, okay, it created dismount points. So what I have to do is take this and it's a little bit offset it, and I just need to assign them where I feel that I want to dismount. So the dismount point is where the actual route of your player is going to be. It's going to be touching when the whole transition, and so this is where you can start having the third person controller enabled and move on and so on and so on. Okay, the only problem right now is that I forgot to add them when we reset the connections, and this didn't work. Okay, if I hit update connections once again, it's going to create a duplicate of dismount points. So what you can do is just reset the connections, refresh, delete the previous dismount points, and hit an update connection. It's going to create them again. Once you create the update connections for the handles, so okay, just move the editor a little bit so it updates. So we have created our candidates. Let's go and refresh all. Refresh all is going to find the draw line, which is in our current script. Okay, and if it's not null, it's going to say refresh. It's true, then it's going to update it. And we need to go into all our points, find the draw line individual, and assign it, of course. If it's not null, then refresh that too, so you can have, when you select a heap position from one client point, you can have them individually. Okay, so I can see this point is connected with what point and with what point. So that's most of it. Let's see the reset connections. Reset connections get points. Of course, we need to find all our points, and for each point we have, we need to go into the neighbors and hit clear, so we'll clear all our connections. Refresh all. Again, we need to update the connections, and then we say reset connections to false. And I actually don't know why I use this. Get all connections. What this does is, oh yeah, we just use this for our editor handle. So get all connections starts with a list. We get all the points, neighbors, and we should actually use this. Yeah, we should probably assign over here the points. Anyway, let's just keep it, because there is a case, although if this is null, then it's just going to return an empty list anyway. So for all our points, gets the neighbors, creates a new connection, and creates target 1 all points. Okay, finds the target 1, finds the second target, and it adds it into it updates the connection type. However, because as I said, one point, if it's connected to another point, you have two neighbor classes over there. Okay, so we need to do a manual if the list contains one of the connections. So what we do is pass the list of connections and our current connection. So if it finds another entry inside our list of connections that has the connection target, the first target is equals with another list, another entry's first target, and the second target is equals with the second target of another entry. Okay, that means the connection is already inside in our list. Okay, so we do not want duplicates. However, because the positions might be different if we're going from, depending on from where you go to where and back. Okay, we also need to check if the target 1, if there is a connection basically that has target 1 assigned as target 2, and the target 2 if it's assigned as target 1. Okay, so basically if it's one way or the other. If it does, then we do not want to add the connection into our connections list, so we do not, this way we take care of duplicates. Okay, we add them to our return value and we go back, and yeah, that's basically it. This takes care of the draw lines. So we saw how we can automatically create a grid. The only thing left to see for our climb grids to be ready, and we're going to go on a working grid actually, is we have our grid, we have our main game object which has a manager script. Okay, this is important, and we also need to have somewhere that we have a collision. Okay, because we're doing a recast to find the collisions. This doesn't need to be to not be triggered. This can actually be a connection that's this can be a mesh collider or something else. We just need a collider. I'll suggest just stay with box colliders, because you know, they have mesh colliders are a bit unpredictable at times, so just use box colliders. There's no need to have a lot of physics calls anyway, so mesh colliders, their value, their usage should be pretty limited. And I'm actually going to say just use box colliders, because if you had the mesh collider on the house, as I said, if you were approaching this side and you were hitting this, even if there was no climbing position in here, then it's going to just let him to the closest one it can find from this one, and of course you do not want that. So just use box colliders, in short. Okay, I have this separated from my grid, so I can do changes easily into my grid, and I have them both on under one game object. Okay, and you can also add the building, but there's no need. And we have a manager script, and what this manager script is, it just has all the points. On start, populates all your points. Yeah, I have start and public void in it. Later on, when we are actually preparing our level, we're going to remove this and just use init, so you do not have all the buildings in your world go and do stuff like this. Okay, so it goes one by one. Okay, populate all points. What it does, goes and finds all points, and for each all point it's going to, if it's not already inside the list, then it's going to add it. Return neighbor point from direction. I use this. I do not use this, so forget this. But basically what this is, you pass an input direction from current point, it's going to return you the neighbor class for the direction. But yeah, I probably just found a better solution, which probably that better solution is this, return neighbor. Yeah, we're going to see that later on the next video. I mean, by later. Return neighbor, input direction, current point, return value for each neighbor we have to our current points. Okay, it's going to compare the direction with the input direction. Return closest, it's going to find the closest point you have into or your list. Okay, the closest point is going to find inside your list. And basically it's what we are using when we are raycasting to find this collider, and it's going to return that. So that's basically, we've covered how we can handle the points and how the anatomy of a point, what it is. We handle how we can automatically create a grid, or basically create the connections inside our grid. We saw how we can make the dismount points. We saw special cases for climbing positions like this, and moving through corners. And I'll just hit play right now just to see that everything works. Okay, all points. You can see that there are a lot of points, so just keep your grids smaller, to be honest. Okay, there's no need, and the player will not even notice the difference that there's two grids. If I separated these points and these points, the player will never know the difference between how many grids there are in a building anyway. Okay, and of course we will see later on how we can connect automatically later on, I mean on another bunch of videos of this. Okay, and yeah, we're going to see how we can connect the grids automatically. Okay, you can see how smooth it is after we finish it. So, as I said, we saw the anatomy of a point, we saw how we can create a grid, how we can update them automatically, all the connections, how we can add manual connections, and what we should probably add later on is have an indicator if a neighbor list, if there's a connection that we have manually placed, then just ignore that when we are deleting all the connections, unless you want to delete, of course, and the manual connections. Okay, and the other thing we saw is how we can have the dismount points, how we can indicate them. So I'm over here. If I click up, I'm going to dismount on that position. Okay, yep. I'm going to hit up. You can see that I'm dismounting on that position, and I can run again. Of course, the third person controller is just something for, it's not something, it's just a simple one. We have other videos with more advanced third person controller. Okay, just watch that, you'll be better off. And if I go from this point, of course, okay, if I hit up, I cannot connect, I cannot reach those positions. And also, if I want to move out, we have the fall, if you want to dismount like that. So that's it with creating the grid. On the next video, we're going to see how we can actually move through the grid, and on the video after that, we're going to start adding the arcade and all the cosmetic stuff we can add to it. So, you know the deal. Like, subscribe, Gumroad, Patreon, whichever way you want to support the making of all these videos. And because, yeah, this took a stupidly amount of research, to be honest, and yeah, this took around 5 to 6 months to create. It wasn't the problem creating the system, it was the problem that making it as stupid, as simple as, stupidly simple, basically. Because, yeah, if you wanted to see previous versions of this, yeah, it was way too much complicated without having any reason to be complicated. Okay, and you can see, you can have, if you want to make a perfect game and you have to look through windows, you can make it come true, you can make your dreams come true with this climb system. So I'll end the video here, and I'll see you next time.